Hi everyone. I hope you're keeping well. This afternoon we are going to be talking about futurology and super forecasting. In other words, trying to predict the future, trying to assess specifically various risks that may lay in front of us, not only as individuals, but also as groups or societies. How can we come up with a fairly rigorous and scientific way of assessing relative risk? Now, a scientific approach suggests that you adopt a particular methodology and that methodology be replicable. In other words, that somebody else could repeat your methods and come up with the same or at least very similar conclusions to you. And of course, when it comes to telling the future, looking into our proverbial crystal balls, that is, of course, very difficult. And what we typically have to do is to try and rely on what happened in the past to inform what happens in the future. So we tend to utilize a range of methods that speak to inference. In other words, taking something we know about and inferring from that thing that we know, something that we do not know, something that has yet to even be. And there are some really fascinating examples of how we are actually really good at this in some instances. And then there are also some examples where we're pretty hopeless, and I'll go through cases of both. Okay, so first of all, what even is risk? What does it mean to face a particular risk? We can think of things to do with specific personal harms, but also social risks as well. This is a very useful graphic that's been put together by the Future of Humanity Institute. The Future of Humanity Institute is the coolest named institute at the University of Oxford. And what it does is, as its name suggests, it thinks about the future of our species. And risk is therefore a fundamentally important part of that assessment because it needs to try and calculate things that could be threatening. And they will look at the gamut, right? They will look at the potential risk of all-out nuclear war. They will look at the potential risks of asteroids hitting the Earth. You name it, they've tried to think about it. They've tried to anticipate the various risks that we face. And this graphic just simplifies some of the ways that we can conceptualize, can think about potential future harm. And as you can see on the x-axis, we've got the severity of those harms from damaging to catastrophic to fatal. And on the y-axis, we've got the range of those harms from the personal to the local to the global. So, for example, a personally catastrophic risk could be, for example, being paralyzed by a car crash. But a globally catastrophic risk would be something akin to global warming of 6 degrees Celsius. A globally fatal risk would be an asteroid that causes human extinction. So it all sounds a bit dark and bleak, but the reason for analyzing these risks is to avoid them, right? So although it can be slightly disturbing to think of these futures where we and those around us could die, of course, the reason for doing that is to stop that happening. Okay, so that's why institutes like the Future of Humanity Institute exist. And they try and pick apart at least 4 different criteria of risk. And they start with known knowns. So these are things that we know that we already know. So they categorize certain risks that we know we already know about. So for example, we know a lot about the risk of different types of transportation. Now, of course, we can't know whether or not a specific person or a specific group of people will be at particular risk when they, say, take a plane or jump in a car or whatever. But we know an awful lot about the relative risks of different forms of transportation. So that might fairly easily fit under a label of known knowns, things that we know that we know. Okay. There are also known unknowns. So those are things that we know that we don't know terribly well. So that could be to do with specific risks to a terrorist incident, for example. So governments around the world are still on a heightened level of alert for a terrorist attack because they know that it is a high risk. They know that there is a high likelihood. They are tracking lots of chatter around the world that gives them a decent basis for that conclusion. So they know that something is likely, but they don't know when, how, where, and all the rest of it. So it's a particularly disturbing form of risk insofar as it is a known unknown. There are also unknown knowns, which is the opposite of that, which is when you don't know stuff that you actually do already know. Now, this is perhaps more likely to occur in an organization. So it could be, for example, that one part of an organization knows something, but the rest of the organization doesn't. So it's unknown by the organization that some people know certain particularly useful things. This emerged in the aftermath of the 9/11 terrorist attacks in the United States. It was revealed that the CIA, Central Intelligence Agency, knew certain things about the terrorists and the attackers, and the FBI knew some certain other things, but they didn't put those things together. They didn't have a full picture. So there was quite a lot of unknown knowns. They didn't have the full picture to look at, and therefore on a macro organizational level, they were unable to take action on their bits of intelligence that they had around the place. And then, perhaps most disturbing of all, are unknown unknowns. And these are things that we don't know we don't know. So we haven't even got the imagination to think them up. They are the sort of risks that are completely unknowable, but they could still emerge. And I suppose we could perhaps even describe the new coronavirus as fitting almost into this category. It was suspected that a flu pandemic was coming. What was not suspected that that there would be a coronavirus pandemic, or that coronavirus pandemic would be of such severe proportions. Now, some people would dispute that, of course, because there were coronaviruses that were going around earlier, and that they did obtain to pandemic proportions. But something of the scale and magnitude that we've been going through over the last 2 years was arguably an unknown unknown until it happened. And those sorts of risks are therefore inherently difficult to prepare for, because you don't know what it is that you're supposed to be preparing for. So when it comes to experts and how they try and manage those risks, they just try and anticipate what sort of remedial action you could take to anything very bad, such as the need to roll out hospitals very quickly, such as the need to mobilize people, materials, resources, you name it, very quickly, so that you can deal with almost any disaster, whether or not it's something that you've got good reason to anticipate, or it's something that you had no clue was just on the other side of the horizon. Okay, on a personal basis, we can also come up with a reasonably scientific way of measuring relative risk. Now, of course, as young adults, you will have a pretty clear sense of what is more or less risky behavior. Simply by living for several years, you will start to accrue an unconscious sense of what is more or less likely to cause you harm. And you may have had a few sort of painful experiences in the past which have helped reinforce those lessons. But we can be much more scientific. That is basically intuition. That's a sort of sense that, given certain things that have happened to me in my own experiences, and given certain lessons I've been taught by those around me, I have a sense of more or less potentially harmful behavior. But we can also take advantage of enormous data sets and the statistics that they yield in order to have a clearer basis for confidence or lack of confidence in certain choices and behaviors. And there's a really fascinating concept called the micromort. It's kind of dark, but in a really fascinating way. A micromort is something that is a 1 in a million chance of death. So anything that yields a 1 in 1 million chance of death is a micromort. Mort as in death, micro as in 1 millionth. And this was developed by scientist Ronald A. Howard, not the Ron Howard of Happy Days fame, but another Ron Howard. And what he wanted was this really sort of rigorous scientific metric that you could compare different risks. So you could say categorically, at least in quantitative terms, that X risk is 5 times more dangerous than Y risk. And you could say that with some certainty based on the statistical basis. Just to give you a bit of a sense of what 1 in a million looks like, imagine you've got a dice and a coin, and you flip it 20 times. If that coin landed the same way up all 20 times, so it's always consistently heads or always consistently tails, that's a 1 in a million chance. Okay, so intuitively pretty unlikely to happen, right? But possible. Anyway, that's what a 1 in a million risk looks like. That's a micromort. And so that can help us to distinguish between fear that could be irrational, could be based on movies we've been watching, could be based on nightmares we've been having, could be based on that sort of hard wiring we have to avoid risks that may have been particularly dangerous to our, pre-civilized forebears, but aren't necessarily, or is not very likely to cause us harm now. So an example of that is the risk of being killed by sharks. There's a reason that there are lots of films about shark attacks. It's because they are monsters and that they will have this insatiable bloodlust the minute you put a toe in the water, and they will desperately want to eat you immediately. Now, of course, the statistics absolutely do not back that up at all. Sharks are not a risk to human beings. Quite contrarily, human beings are a devastating risk to sharks. And we can back this up with good data. We can use micromort. So I can tell you, for example, that there is a 0.125 micromort associated with shark attack, and that's for Australians. So that's for people that live in and around the habitats of the world's most dangerous sharks. For us in the UK, that figure is going to tumble substantially lower. So that's a 1 in 8 million chance of an Australian losing their life on account of a shark attack, meaning that Australians have almost as much of a risk from dying in a kangaroo attack. So what we have with micromorts is a really clean statistical basis for comparison. We can say that basically your chances of being killed by a kangaroo are about as great as your chances of being killed by a shark. And yet we don't have many horror films about rampaging killer kangaroos that are hopping around, eviscerating people. So it shows that quite a lot of our approach to risk is based on culture and how culture seeps in and digs into our sort of primordial brains that sort of says, we're going to be killed by dangerous creatures in the forest, when actually that's incredibly unlikely. So here is a nice little table that gives some interesting comparisons of different risks that we take in our lives. So walking 27 miles, which is a long old walk, that comes with a 1 micromort, 1 in a million chance of death. Okay, cycling 28 miles, same. And riding a motorbike 7 miles is the same. Driving 333 miles. Train for 7,500 miles, and a commercial aircraft for 7,500 miles. So interestingly, traveling by train or traveling by commercial aircraft is about the same degree of risk. A light aircraft for just 15 miles is again a 1 in a million risk of dying. Rock climbing, however, you're up to 3 micromorts. Scuba diving, 5. Just working, any occupation for a year, 6 micromorts. So you should be more scared. You should be 6 times more frightened of going to work than getting on a plane and crossing the Atlantic. Now, this doesn't sort of square with our intuitions. Plane flight is much scarier. I suppose, and I'm speaking from experience, right? I find air travel quite scary. I know that statistically it's unlikely that you'll die. It's actually an amazingly safe form of transport. I suppose it's not just the risk that bothers me, but just the thought of how awful it would be to die in that way. Anyway, at least according to the scientists, the number crunchers, we should be just as worried about going to work as we should getting on a plane. Well, no, we should be much more worried about it. Running a marathon is even more dangerous still, 7 micromorts. Hang gliding is only marginally more dangerous than that, though. Skydiving, 10 micromorts, which makes it as dangerous as receiving an anesthetic. Giving birth is also about 10 micromorts, but cesarean section, I'm getting wrong, sorry. Giving birth is 120, cesarean is 170. Coal mining is more dangerous still, 430, and as dangerous as base jumping. So base jumping and coal mining are equally as dangerous, it would seem, according to the statistics. Commercial fishing, 1,020, and finally climbing Mount Everest, 12,000 micromorts. So that sounds pretty dangerous. Okay, so I mean, this seems like a fairly jovial way of looking at something incredibly dark, but the point is that it just gives us some sort of basis for for value neutral comparisons, where we are trying to calm the part of our brain that is constantly terrified of threats, and that source of primeval terror, which is used to such great effect by Hollywood in producing horror films, doesn't square with the essential reality, which is that there are some things that are far more or less likely. Now, as mentioned earlier, the best we can hope to do when it comes to predicting future risks is looking at what's happened in the past. So we only ever have that as a basis of inference. That doesn't mean that anything, of course, is ever guaranteed, and the statistics will be revised all the time. In fact, one way that we often utilize inference in a sophisticated manner is called Bayesian inference. Bayes was a mathematician, and he came up with this way of continuously revising and improving our forecasts based on more and more information. Let's say, for example, that you're stood at a bus stop and you see a bus go past. So you know that buses stop at that bus stop. So you now can develop an inference that buses will stop here in the future. This is not just a one-off. Then you see another bus stop and at the bus stop, and so now the second bus has arrived about 15 minutes after the first. So now you're beginning to get a few elements for your forecasting. Not only do buses stop here, but they stop here about once every 15 minutes. And then a third bus comes along 15 minutes after the second bus. And so now you're further refining your idea that buses will stop here every 15 minutes. If a fourth, fifth, sixth, seventh, eighth bus again arrives 15 minutes after each one, you're further refining your inference, and your predictability will become better and better and better. And that approach to Bayesian inference, as it's called, is utilized in all sorts of different contexts, from things like machine learning and artificial intelligence to being some of the more rudimentary bases of things like weather forecasting, although weather forecasting uses these days incredibly sophisticated supercomputer models. But the fundamentals of making predictions are, you look at the past to predict the future. In my own domain, political science, you may have seen how on election night the psephologists, those are people that look at elections, will consider how a certain constituency voted in the past in order to try and inform how it's likely to vote in the future. And they will revise those predictions based on things like exit polls and any other polling data that they may have. So given all of this data that we have on past behavior and revising that with new data that we've had even more recently, we can conclude with some degree of confidence that this is what's going to happen in the future, but it's never guaranteed. Okay, now the reason I've got a picture of someone's chest here is because actually one of the gravest risks that we face is heart disease, and yet this is something that we are not particularly attuned to, even though there is oodles of evidence on this, and it should be the sort of thing that does scare us. We are surprisingly blasé about it. So specifically, 26% of UK deaths every year, over 1/4 of the people that die every year will die from complications relating to heart disease, such as cardiovascular disease and coronary heart disease. 1/4, 1 in 4 people will die of complications from heart disease. That's roughly 1 person every 8 minutes. Now that's what horror films should be made about, unhealthy lifestyles, because that's the stuff that kills people big time. And yet we don't really see that as risky necessarily. So it's quite astonishing how, as a species, we've come up with some fairly sophisticated ways of trying to predict the future, and yet we have also some incredible blind spots. And one of the reasons for that is likely to be an optimism bias. Human beings are interestingly quite optimistic, especially when it comes to assessing personal risk. So they may know the statistics on certain things, but there is also a recorded incidence of humans being quite poor at associating those risks with themselves as individuals. Oh yeah, I know that smoking is bad for other people, or I know that, you know, eating junk food is bad for other people, but it's going to be fine for me. Or it might be difficult for me, but I can do it for a few years. It'll be fine without any consequence. I'll still live and it'll be all right. But the statistic says, no, you're wrong. You know, that sort of blithe optimism doesn't square with mathematics. So it's really intriguing how we have all of this sort of sense of, well, I mustn't put a foot in the water in case a shark gobbles me up, even though there's a really teeny weeny chance of that happening. But sure, I'll snack on this fish and chips by the coastline, even though that's the thing that's more likely to kill me. Anyway, don't get me wrong, I'm not some sort of killjoy that never has fish and chips or junk food, or, you know, has a day without doing exercise or something worthy like that. Of course, I'm the same. So I'm not sort of pointing this out in a sort of holier than thou, finger wagging, oh, you people with your heart disease. You know, this is something that runs in my family, so it's something that I've got to be careful with. And being optimistic is just not a clever strategy when it comes to these things. I suppose what strikes me is how interesting it is that we are incredibly optimistic about our chances of surviving heart attack, stroke, you name it, and yet incredibly pessimistic about our chances of getting out of paddling in the sea alive. Anyway, therein lies a tale about human psychology. So what are considered to be the gravest public health risks? Now, this is the top 10 list that was put together by the WHO, the World Health Organization, in 2019, so just before the pandemic hit. And interestingly, they had anticipated a pandemic of sorts as their third highest risk. A flu-type pandemic, I suppose, would have been more accurate, but we'll let them off the hook for this one. But they're talking very long-term risks. So they're trying to work out the total numbers of people likely to die or have their lives seriously affected over the next 50 plus years. And so their conclusions are that air pollution and climate change is number one. And we can see that there are consequences of this already. I mean, air pollution is a major killer of people in London, for example, already. And climate change, we've seen, has wrought havoc in Germany recently and various other countries around the world. So climate change does pose a grave threat to our lives. Non-communicable disease is number two. Flu pandemics, then vulnerable settings. So that could include settings that are vulnerable for geological reasons. So it could be that they are going to face landslides, earthquakes, volcanoes, or vulnerable in a more sort of socio-political sense. So it could be that they are war zones, for example. Number five is antimicrobial resistance. So this is resistance to antibiotics that will mean that bacterial infections will become deadly again. Number six is Ebola. Number seven is weak primary health in particular contexts. Number eight is vaccine hesitancy, which again is quite interesting given what we've seen recently about that as a problem in the light of the COVID-19 pandemic. Number nine is dengue fever, not going to be relevant to the UK, but is a severe risk in other countries. And number 10 is HIV. So those are the public health risks that have been identified by the WHO, and they've basically done the number crunching that I've described. They've been looking at the past, and they've been performing some forms of inference. They may have done Bayesian inference, I'm not sure, but that certainly would have been a rigorous way of doing it to try and work out, well, given these are the number of people that have died from certain risks in the past, this is what we know about the trajectories of those risks going to the future, such as worsening air condition and how that's likely to affect the death of people. And crunching all of those numbers together, we can calculate a range of possible deaths from those outcomes. Okay, now working out how to model these risks, especially sort of global macroscopic risk, is part art and part science. Now, I mean, realistically, it's all science, but there's some artistry in it insofar as that there are important choices that have to be made by the scientists. For example, you have to frame the right question, right? If you're trying to assess a risk, you need to make sure that you're asking the right questions about what those risks may be. Remember the unknown unknowns? Well, if you don't know what questions you should be asking because you have no conceptual framework for anticipating certain risks, then it's very difficult to prepare some research on that. So we need to be very careful as to how we even ask certain questions about what's likely to be risky in the future. Okay. I mean, for example, prior to the 9/11 terrorist attacks, there was really no one asking the question as to whether or not aircraft would be used as missiles on such a scale. Of course, hijacked aircraft and planes being used as missiles was conceived of as a risk, but not on the degree of risk that it turned out to be. Okay. We also need to be conscious of any assumptions that we may be making. So, for example, there was a lot of research done as to the likely risks posed by a flu pandemic, but then in the end, the pandemic we had was not a flu, not influenza. So can we make assumptions and predictions on the basis of flu for other forms of communicable disease? Is that going to be a reasonable assumption? An example that I've got here is this is the research from Imperial College that formed the basis of the first lockdown in the UK. They did modelling of the likely mortality rates of an uncontrolled pandemic, but they had to base their assumptions and their data sets on flu pandemics because that simply was the best available data on communicable disease transmission and mortality. So they had to take some difficult choices with regards to modelling. But of course, that's an imperfect comparison. Comparing flu to coronavirus is okay if you have to make that comparison, but it's not a perfect fit, and therefore the predictions were not perfect either. But that's just in the nature of modelling. Sometimes you have to come up with some sort of an analog. So it's not going to be a perfect data set because we don't have perfect data sets for the future, obviously. So we have to sometimes cobble together things that might work just about, but who knows? Okay. And that links into choices of data and availability of data. Then we need to think about the error and the refinement. So when you're doing Bayesian inference, you always need to try and refine your predictions based on any new information that you receive. And you need to feed that back into your models and improve the model refinement. Even if you've perhaps generated a certain head of steam with a particular prediction, it's still important to refine your models. Now, let me give you an example of this. So prior to Brexit, the polling companies and political scientists and psephologists were all predicting, well, not all, but mostly predicting that the UK would not vote for Brexit. And to a certain extent, that was because some early polling data suggested that was the case. And so they started publishing stories saying, well, the UK won't vote for Brexit. But they also then stopped adding in new polling data as it came about. So polling data that came towards the referendum itself was beginning to show with increasing rapidity that actually Brexit will happen. But at that stage, these big companies had a reputation to uphold. They didn't want to be the ones to stick their necks out and say, actually, I kind of think Brexit might happen now. So they didn't say it. But what they should have done was to notice the errors in their models and refine them based on new findings. They didn't do that because they were embarrassed or didn't want to be embarrassed by being the ones that said, actually, what everyone else is saying could be wrong. So this is a big risk. And a similar thing happened in the US presidential election in 2016 between Hillary Clinton and Donald Trump. Even though data was increasingly saying Donald Trump's going to win this thing, the big companies were just too embarrassed to admit that that's what their own models were telling them. So error and refinement is so crucial in modeling. You can't just keep going down the same path if the data is saying you're wrong. You need to revise this. Okay. And there's also an important role for public communication that, scientists and others that are in the business of assessing future risks and opportunities need to try and take people with them. Otherwise, we could end up with some extraordinary social problems if people just don't understand why they need to behave in certain ways in order to mitigate risks. Various examples could be thought of for this. I mean, managing climate change is perhaps a clear one. That in many contexts, people have not been told of this in sufficient detail of the extent of risk of climate change to their lives, to their families' lives, and to the future of their civilizations. And because of not being clearly communicated with, they're not necessarily taking the sort of steps that might be needed in order to try and manage those risks. So public communication is crucial, but sometimes scientists are not necessarily that good at it, in all frankness. Okay, so what about the sort of the extremely long term? I mean, we may be relatively good at predicting when the next bus is going to turn up, but when we're talking about the next century or the next 1,000 years, things start to become very murky very quickly. John Maynard Keynes, the economist, famously said, "In the long run, we're all dead." So, that was one prediction that he thought was pretty solid. And we have certain clear ideas as to what the long term could look like. I mean, I've given some examples of pensions and climate change. We know, for example, that there is a crisis of pensions coming. We've watched it since pensions were instituted over 100 years ago in the UK. Climate change, similarly, we've known that for a long time that the world is on a path to trouble with climate change. So we're sort of watching these things play out in a very slow process. But there are still so many unknown unknowns. And in particular, as a result of technology, there are lots of things that we don't know are around the corner. And one fascinating possibility is transhumanism, which is the possibility that we might transcend our own biological limitations. And so I pose the question, is the first true millennial alive today? And by true millennial, what I mean by that is the first person that lives to 1,000 years old. It's been suggested by some scientists that the first person to live to 1,000 is already alive today. And so John Maynard Keynes could be kind of wrong. And a lot of our prognostications around pensions and climate change could also be wrong because of the extent of technological advance that we are as yet ignorant about. That is the unknown about all of this. We know what we know about pensions and climate change, but we don't know what technology could yield in the next year, 5 years, 1,000 years. Okay, so that's what always makes super forecasting quite exciting. Are there any risks inherent in being risk averse? So if you're constantly trying to avoid risky behavior, you're taking lots of precautions, is that itself risky? It's maybe sort of slightly self-reflective, but yeah, I mean, it kind of is, because, or at least it can be, we've got to acknowledge the amount of doubt we have about predicting the future. So if you take lots of very sort of cautious behavior, then you could be missing out on opportunities which are unnecessary. So for example, I mean, going back to an extreme example, let's say you've always wanted to go scuba diving, but you've decided not to because of the fear of being killed by sharks. Well, as shown in the tables earlier, scuba diving itself is vastly more dangerous than the likelihood of a shark attack. It's scuba diving, I think, was 8 micromorts, whereas shark attacks was 0.125 of a micromort. So it could be that you self-harm in that instance in a trivial way, but in other instances in your life it may not be trivial. You might miss out on things that could help with your personal development on account of risk aversion that is not based on any likelihood, but based more on fear. So that's a possibility. There are risks in that sense. There are other more sort of social risks that if we mitigate risks now, then we have to wear a hair shirt about it. So we have to, if you like, somewhat make our lives more difficult, for example, to tackle climate change. And we're doing that for generations of people as yet unborn. And some philosophers have misgivings about this. They say that that is a straightforward unfairness, that our generations, not that I can really sort of associate myself with your generation, but anyway, at our age, we're going to have to do a lot of work to try and tackle climate change so that future generations that haven't been born yet will reap those rewards, or at least will have an Earth that is still habitable. I mean, so reward is perhaps the wrong word for it, but can even come into being. But anyway, some philosophers say that that's terribly unfair on us and terribly unfair on people that aren't planning on having children. So why should they have to forego the various pleasures of the here and now just for someone who's not even alive? It's an interesting question, but I'll leave it up to you to think about it. There is also some problems if you try and mitigate a risk and then that risk turns out not to have materialized, it can start to delegitimize your voice. So if you're a government scientist, for example, and we're seeing this quite a lot, and you say, well, there's terrible risks to doing this behavior, such as going outside without a mask, or terrible risks to having children in schools, and then those risks don't necessarily seem to come to fruition in the way that you described, that can start to delegitimize your voice. Now, I'm not trying to point to any examples here. I'm not saying that scientists have predicted certain things about the pandemic that haven't come true. And of course, part of the problem is that in managing those risks, the likelihood of it happening reduces, right? So it's always problematic if you say, right, we need to make sure that children don't go to school, and that if anyone gets a positive test, you need to take everyone out of school. That is managing the risk. So you can't actually prove the counterfactual. You can't prove that if you hadn't done that, things would have been worse off. So it's very problematic, but it does lead people to become quite cynical fairly quickly, because they start to think, well, there's this hysterical brigade of risk managers who are telling us not to do this, that, and the other, but actually the risks are tiny. And we sometimes get this notion of the debate in what's sometimes fairly lazily called political correctness gone mad. So it could be, for example, that you're told that you're not allowed to play certain games at school because of the potential risk to your not your life, but at least to you getting an injury from doing so. And so people become quite health and safety conscious based on the statistics of the number of people injured in those behaviors. So anyway, these are some things that can start to alienate people, and hence that can lead to various critical responses, and it can lead to a bit of an industry in basically calling out risk assessors and telling them that they are wrong, even though mathematically there could be a sound basis for their conclusions about risks. Okay, conclusions. So risk assessment and the mitigation of future risks needs science, and by needing science I mean it needs replicable methods that people can independently pursue and reach the same or similar conclusions. But it also needs social science, because we need to think about how we can take society with us. If we reach certain conclusions about the risks of cardiovascular disease or the risks of climate change, how do we encourage people to follow our prognostications without alienating them, without telling them, oh, well, this is all your fault because you've been eating too many chips and you've been, burning too many fossil fuels. How can we have that conversation in a respectful way that yields the results that we're looking for? And that's not a straightforward question to answer. And sometimes scientists are particularly ill-equipped to answer those questions. So we need a bit of social science, and not just social scientists, but just that sort of general sense of how do we encourage people to go along with this stuff. And we also need humanities. We need to think about how we communicate these ideas, how we sort of pose in compelling writing and other forms of communication to encourage people to go along with these different approaches. Okay, and one thing to think about is that it's not just a question of allocating money to the problem, but also allocating what's called social capital, which is where we encourage people to work cooperatively together, and society becomes its own resource for its own protection. And that will come if we have more faith in the industry of assessing future risks. So it's an interesting old business. It's complicated and difficult, but at least with things like micromorts and Bayesian inference, we do have the rudiments of mathematics to predict the future. The only problem is that we have a lot of unknown unknowns about what's coming tomorrow, and that's inherently problematic. And the best way to mitigate those sorts of risks is to just come up with some systems, some processes to manage anything risky, regardless of what it may be. Okay, thank you so much for listening and watching.